Okay, so here we're going to prove the triangle inequality theorem. It says that the sum of any two side lengths is greater than the third side if and only if it's a triangle. So basically, it's two directions. So I'm going to prove that if the sum of any two side lengths is greater than the third side, then we can construct a triangle. So basically, what does this way say? It says, if we have A plus B is greater than C, then we can construct a triangle. Then we can construct a triangle. How? Well, then we know that if I draw this length C, this is some length C, and I have some length A, let's say, I don't know, this length is A, and then this length is B, right? And this length is B, then we know we can construct a triangle because you draw this circle, right, of length A, and then you draw this one of length B, and basically you can see that then there'll be two triangles, or really one, right? But this triangle, right, this length is B, this length is A, and then this length is C. So you have it in the configuration A, B, and C. So if we have three sides with A plus B greater than C, then you know you can construct the triangle as follows. Then you have that. Now, that's one direction. And the other direction is very similar. You use this construction. So now we say if it is a triangle, then you must have, right, that that the sum of any two lengths must be greater than the third lengths. Then, right, then let's say in this, these are the side lengths A, B, and C, right? I want to show that the sum of the two smaller side lengths is greater than the third side. So let's just say again that C is the largest side, or one of the largest sides, because it could be an isosceles, right? With the shortest side, these two are congruent, right? Then you pick this as C, this would be B, this would be A. It's obvious that A plus B would be greater than C, but okay, let's just say that C is one of the larger ones, okay? So we know that C is greater than or equal to B, which is greater than or equal to A, something like that, okay? Where there could be equality among these, but C will be the longest side. So if you draw C as the longest side, right, we want to show that we know it's a triangle, right? We want to show that A plus B must be greater than this C. So if you have it, right, you could prove the contrapositive a better way, right? Then, so what would be the contrapositive of this? The contrapositive of this is if, right, A plus B is not greater than B, then there can be no triangle. No triangle exists. And that's a little bit easier to prove, and that makes a little bit more sense, but you should see this as being the case, right? So if it's not greater than, then you should see that this length would be A, or this length would be A, and then this length would be B, and you should see that A plus B won't be greater than C, and you should see that if I draw all the possible triangles, a circle around A and a circle around B, they'll never intersect, so no triangle can exist, and you're done. Okay, and you could say that if a triangle exists, you must have it that if this is C, right, and then this must be something like A, and then this length must be something like B, and you have something like that. And then this is your triangle, okay? But it's better to prove the contrapositive in this direction. So a better way to say it is that if, right, so what's the contrapositive? So the contrapositive of this direction, right? The regular way to say it is if it's a triangle, then the sum of any two side lengths is greater than the third side. So the contrapositive of that is if the sum of any two sides is not greater than the third side, then there's no triangle. And you can prove that one with just this diagram right here, right? This is the contrapositive, and you can just draw a picture showing that it doesn't matter. If this is C, then you should see that A plus B, if A plus B is not greater than C, you could sit here, you could try and get this to meet at B, but it will never meet exactly at B. The closest it'll get is if they're both lying flat on this side length C, which can't occur. And that won't, or that won't be a triangle anyway, but it doesn't even meet at that point, which is why you need A plus B to be greater than C. This is more or less the idea.